Welcome to Chapter 10, Preparing the Quantitative Analysis. Welcome to Chapter 10, Preparing the Quantitative Analysis. When you're cleaning the data, you are laying a foundation for your future analysis and the house that you'll build on that foundation. So it's important to get it right, get it square, and make sure your data is clean. There's a sequence to this in terms of questionnaire checking, coding if you have open-ended responses, and transcribing any open-ended responses, but also get into data cleaning. And you're going to find that the majority of your time in a data analysis project is spent on data cleaning. Anywhere up to 2/3 to 70% is just getting the data correct in the spreadsheet or the database that you have. So this is a frequency distribution. The question had to do with familiarity with artificial intelligence. You see the values range from 1 to 7, but then there's this missing value here, and that is 9. So that was designated as a missing value. So somebody didn't respond to that. When the bar chart is produced, that missing value does not appear, but we'll have to deal with that later when we come to doing statistical work. So if you have non-responses or inappropriate responses, you could return to the field. That's expensive. It's time intensive as well. So you're more likely to assign missing values. You can also discard unsatisfactory respondents. Sometimes there's a key question in your survey that you really want. That's the dependent variable. It's the focus of your study. If people aren't responding to that or giving a missing value, you have to drop them, the entire set of responses for that individual from your analysis. You can substitute a neutral value. It's typically the mean value for the variable. You can do an imputed response. This gets more complex, where you have to come up with some calculation for what's the likely response for somebody who's missing there. And then it's a case-wise deletion. You can delete respondents, or you can do a pairwise deletion in your analysis. So you would keep all the cases with any missing values, but you wouldn't include them on analyses that had that variable in the analysis that it was required. You can respecify variables. So you can, this is part of data cleaning. You're preparing it for a different phase of analysis. So you might have an set of attitude questions, good, bad, favorable, unfavorable, like, dislike, and you would just add these, and that would be your new variable. So that's a composite variable, an item parcel, or an item bundle. That sometimes, or many times, makes it more simple to, instead of working with 3 results, you're working with just 1. Dummy variables are also possible. So these are respecifying categorical variables. So you might have these categories: non-users, light users, medium users, heavy users. So you'd actually create 3 new columns in your data set, and those 3 columns would comprise your dummy variable coding. So the new variable for non-users would have 1 and then 0, 0. A respondent that were light users would have a 1 value in the X2 column here and zeros in the others. Medium users would have a 1 in the X3, and then the heavy users would have just all zeros there. So it really winds up being a grouping variable. So you can, for your dummy variable coding, that can be included in regression analysis, as we'll do that later. Scale transformation. Sometimes you need to go to standardized variables, and a way to do that is to each response would then have the mean value subtracted from it, and then that would be divided by the spread in the data, and that would give you this is the sample standard deviation. That would give you a Z score for that person's response. We've got, let's see, measures of central tendency, the mean, the mode, the median, the, let's go back here. Okay, the mean is the average. The mode is the most frequently used response category. Then the median is which response category separates the 50th percentile. So 50% of the respondents are below that category, 50% are above. So the variance, you have this equation here, the sum of all these respondents' responses minus the average value squared. You sum all those up and divide by the sample size minus 1. That will give you the variance for the sample. To get the standard deviation, you would just put that under a square root. So, and then by using the square root, it returns this standard deviation to the original metric of the variable. So if you had a 0 to 1, 0 to 7 scale, once you use the square root here, this standard deviation would allow you to meaningfully understand the spread in the distribution across a 1 to 7 scaling. And that makes it more interpretable. The range for distribution, would be the largest minus the smallest value. So if you had a 1 to 7 response in your scaling and respondents use 2 through 5, 2 through 5, then your range would be 3. And so this gives you some indication of how respondents used your scale. Interquartile range is the difference between the 75th and the 25th percentile. Skewness and kurtosis give you an understanding of the distribution here. Skewness is, whether the tail is in one direction or the other, and kurtosis is the peakedness of the data here. So here we have a symmetric distribution there and a symmetric distribution. The mean, the median, the mode all line up on the same value on the baseline there. With a skewed distribution, the mode will be over here, the median here, and then the mean might even be over to the left of that. So you have this long tail. A lot of times, even practitioners do this. They'll say that this is right skewed, but it's not. This is left skewed. It has to do with the tail. Okay, yeah, the hump of the data is over to the right, but the tail is to the left, so that is a left or negative skew. Okay, and if it's skewed in the other direction, in other words, you have the hump on the left and the tail on the right, that would be positive skew. So those are technically correct terms in use here. Interestingly, this is what a lot of marketing data looks like when you're talking about satisfaction or attitude. These are successful businesses. And so, yeah, customers like them, and they have a skewed distribution here. You might have a bimodal distribution where you have a hump to the left and a hump to the right. So that means you've got polarization. People either hate or really like something. And so there's segments there. I think that's the indication for marketers. Okay, preparing your data for analysis, validating the data, making sure the data collectors did their work appropriately, looking at those paper forms to see if they're completely filled out. Sometimes if you give them to respondents, they'll doodle on them or make comments like, this is a stupid question. If I see that on the forms, I throw them out because, or I look at the question and see if it was a stupid question. But if the respondents are, I don't know, ridiculing science or the scientific process, I believe that they are not responding for the rest of the responses appropriately. Data entry. This is a Macintosh computer. I used this for data entry for a survey I did. It was done at in Atlanta, had to do with advertising response. It was a long survey, and the data entry, the numbers there were on the top of the keyboard. And so that screen was 8 inches in diameter. It took me 2 weeks working 8 hours a day to do that data entry. Uh, it was mind numbing, and I had to be relentless to it. When I went to my uh, research agency, SDR Incorporated, at one of them building, they had data entry services, and there would be like 4 ladies in a carousel, and they would take all the surveys and they would enter them twice, and then they would check in the data file, the 2 data files, for discrepancies, and then they would go in and make the changes to correct them. And within 2 hours, you'd have all that 400 done. So it took me probably 100 hours to do that data entry project on a Macintosh computer. I became nearsighted. So this is no joke. So, but there are other ways to get data entered, and you know, it's a breeze when it's done the right way. Today, using online data entry, if done right and set up, a lot of times, or most all the times, that those you don't have data entry errors unless the respondents actually hit the wrong key, but they're not hitting an out of range key, and you're counting on them to make the right entry. But anyway, everything's going to be within the 1 to 7 range of scale that you want. And according to our textbook authors, 60% of data collection is using this online survey approach. And I think that's a positive for you in your future here, that you won't have to be in this tedious and mind-numbing data entry mode that I was in back in the day. Software for statistical analysis, JUMP programs, SAS, SPSS, even Excel. You can run consistency checks because you can actually tabulate data and check and see if things are out of range. Here's what it looks like in SPSS when you look at a spreadsheet. Basically, is what this is. I guess this is in Excel actually. And so you see that the columns here are the variables: respondent ID, the market, the city. There's a code for these, and then the respondent ID. Each of these are a unique identifier for each of the respondents. So the respondents take up one line in the data set here. Then you had 3 questions: question 3, question 4, question 5. And we see here in question 4 already there's a missing response here for this respondent. There's a missing response here for this respondent, a missing response here. Here, someone has entered a -9 for, okay, they saw a missing response and they entered it as a -9. And that was what the data entry people used to signal that this was a missing value. So what do we do with those? I mean, if we just go forward here and do a tabulation, you get this -9 over here across the range of 1 through 7. Well, that's going to pull down your mean of this distribution to 5.04. You don't want that. This just means that nobody responded, but you had to use this code of -9. So you can change it to a missing value, an empty cell in your spreadsheet. This is what the resulting tabulation would look like. Now you have a mean of 6.01. Probably the better response is that you would actually go and insert 6.0 as representing a neutral value for each of these missing values in that column. And so you see this jump here that now 6 is the modal value in the distribution. And we'll just go back here. So once you did mean substitution here, this jumps up to be the modal value. Okay, and so this would be your resulting correct distribution for going forward. When you do a neutral value insertion here, it doesn't change the correlation of this variable with other variables because it's a neutral or mean value. So that's the reason that the mean value is selected there. Missing values, this takes a lot of thought, how to do this, and whether you whether they actually delete respondents for having too many missing values and not having their brains engaged, for example. This also has to be done in a thoughtful way. There's this rule of thumb that if you have 10% missing for a variable, maybe you should reject that variable. You could go to the field again, but it's probably an indication that maybe that question is a difficult one for the respondents to ask. There are some variables like annual income. Some people just are averse to listing anywhere what their annual income is, so they will not reply to that. If you're in another country where they don't have W-2 forms, I mean, like Mexico or other developing countries, people are just working in odd jobs and helping out their relatives and getting meals for that. And to ask them what they made last year is it's a complex question. So that income question is one, though, that you're probably likely to get less of a response for that than you would for others. But I think this non-response is a gauge that something might be wrong with your survey, your questions. Maybe the survey's too long. All that to help you improve things in your data collection effort. An outlier is an atypical response. So everybody seems to be over on the right side of the distribution. This person is way over on the left. Why might that be? Straight liners, they just check one response every time, all the time. And they're trying to just speed through the survey there. Okay. Okay. All right, doing tabulations. Reasons for this is to look and see at the spread in your data, and also is your data within range the way it was on the survey, and you get an understanding for your data here. So here you have the Mexican restaurants eaten in the last month. Here are the possible restaurants here, and you get the actual counts from the survey response. The total is 493. Here you get percentages for these, but you do have responses for none and don't remember. And so here you get the valid percent here for these response, and then you get a cumulative percentage. You're summing all of these up here. Okay, so if you wanted to say that maybe these restaurants above Jose's Southwestern Cafe were on the south side of the city, and Jose's and all the others would be below, then you could say that 74.6% of the respondents were for Restaurant South on the south side of the city. Here you get missing data and how that can be adjusted. Here the responses range from very infrequently to very frequently. So you got a total of 414 for those that responded to that question. 13 did not. There were 427 respondents. So here you get 3% of your respondents were missing. So the valid response here are listed here, but you can see there's an adjustment made that now the valid percents don't take into consideration the missing values. So these would be the more truthful percentages of who did respond to the survey. And then you get your cumulative responses here. Again, you might say if you were looking at top two box, that you would say that 54.8% were below the top two box. So that meant that you had 45.2% that were giving the top two boxes here. Now, I did a study at University of Texas at Arlington back in the day. It had to do with their reported educational plans of non-returning students who had not come back the current semester. When this slide was presented, that 48% of these people we had contacted said that they were going to return to the university this year. One of the senior administrators of the university in a dark room that hit the PowerPoint going, he exclaimed, "Thank you, Jesus." So what he meant was that was exciting news that we hadn't lost these students. They intended to come back, or at least half of them did. But up to that point, it was unknown how many would actually come back. So the point here is that sometimes these tabulations, that is the big takeaway from the study. You can do other subgroup analysis and regression analysis later, but somehow just in the descriptive statistics, that big headline, and for that university and their administrators, that 48% intended to come back, that was the big news, and that was exciting. It mattered a lot to them. Okay, look forward to being with you in our upcoming studies on as we get into chapter two and get into cross tabulations and other statistics.